Okay, and here is number 4 from the homework, graphing quadratics number 1. Okay, so once again, we're going to start with our equation. I've kind of got a little more set up here, so the video might be a little bit shorter this time. Okay, so I'm going to identify my A value, which is 3, my B value, which is -6, and my C value, which is 5. A, B, C. Then we have our x-coordinate of our vertex is negative b over 2a, so it's negative parentheses over 2 parentheses. I'm going to put the b value in the numerator, and I'm going to put the a value in the denominator. Negative negative 6 would then be positive 6. I don't know why I wrote the positive sign, but I did. 2 times 3 is 6, so 6 over 6 is positive 1. So we know our x-coordinate is positive 1. So then we want to take our equation, and we're going to plug 1 in for both spots for x. I'm going to plug a 1 in here and a 1 in here. Okay, so now I want to evaluate this. Once again, if you want to plug this into a graphing calculator or a scientific calculator, it'll do these steps for you. If not, you're going to first take care of the exponent. 1 times 1 is 1. 3 times, now the multiplication, 3 times 1 is 3, -6 times 1 is -6, and now add these three numbers together, and we should get positive 2. Okay, so that means that the vertex would be positive 1, positive 2. Okay, so I come on over to my graph, and I know it's a big graph here, just like your one on the worksheet. It's going to have to go pretty far up. One thing we will notice is that this a value is positive, so that means that the graph will, in fact, open up. And you're going to see that the bigger this number is, the more that graph's going to be stretched out. Instead of the points being closer together, they're going to be farther and farther apart. Okay, so let's take our first two odd numbers. Let's take our a value, which in this case is 3. And we're going to find our vertical change. 1 times 3 is 3. 3 times 3 is 9. Those are positive numbers, so we are going to be moving up. The horizontal change is always 1 to the right. Always 1 to the right. So, actually, I didn't even plot the vertex yet, so let me plot that vertex. There it is. So my first vertical change is 3. So I'm going to go up 1, 2, 3. Always 1 to the right. Then I'm going to go up positive 9. 1, 2, 3, 4, 5, 6, 7, 8, 9 over 1. Okay, that on your graph, I think that point actually is, let me see here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. That's where y equals 14. So to give you an idea of on your graph where everything is labeled. 1, 2, 1, 2. 1, 1. Okay, now it's a little tougher to draw a smooth curve here because these points are so far apart. But just do your best job of drawing the curve through. Okay, to state the domain and range, I'm going to write that right here, D and R. The domain, we're going to say, is all real numbers, once again, because you can plug any single number that you have ever worked with in your life in for x. It's possible. The range, there's a restriction again, because it's not possible to get any y values down here. This is the lowest point of the graph, so we know it has to be greater than or equal to this y value. What's the y coordinate? That y coordinate of the vertex is 2. You're never going to have any y values down here. They're all going to be greater than, above that positive 2. Hope this helps.